All right, here we go. We'll talk at the end of the class, okay? Because I just want to keep going here. So this is just like factoring. It's just like M&A factoring. But now the x squared term has a number in front of it. But now. And say example 2x squared minus x minus 6. Okay? So the only difference here that we did before is that there's a number in front. Okay? This makes this a lot more difficult for students over the years. And I don't even think I want to talk about Steve, I'm not even going to talk about the secret way to do it faster, the old one, because people get so confused which one to use it and when you can't. So the thing is, you can't use a sieve on this one. You can use it with just plain x squared. Okay. Yeah? No, because one's an x squared and one's an x, right? So x squared and x can't go together. Okay. Okay, so we're going to do this one in a second here. So just to make sure everyone gets that written down, and there's just two slight things that are different here. Okay, so I just want to.
Please excuse the interruption. There's a presentation in the co-op classroom beside the innovation space for all grade 11 and 12 Saugeen and Nawash students. The presentation is by Fanshawe College. All Saugeen and Nawash students, presentation in the co-op classroom beside the innovation space. Thank you.
Okay, so you see that the only difference, right, is you see there's before the x squared, there's a number, that's the only difference. Okay, but it makes things not a lot more difficult, but on a test when there's like 5 different ways to factor, it makes this is the most confusing. Okay? Now things aren't actually changed at all. So I'm going to do example 1 is actually going to be factored out. Now I'll do some of these for example. My notes for an example I use. Here we go. Factor 6x squared plus 17x plus 12. Okay. There is one major difference between this and the last action. There actually isn't really a difference. You're right there, Alex? You want to try and write this down or not really? At least the examples of it. Okay, the difference is, so this is like A and B and C. Listen up, please. Okay? The multiply is equal A times C. Okay, that's what the end is going to be instead of like the adding, which means it's going to be 6 times 12, which equals 72. So the multiply, instead of just doing C, it's actually A times C. It was the same thing in the last one because the number in front of the x squared was just a 1.
Wait, why is there a dot?
That's multiply. Okay, the adding is still B. Okay, so we need something that multiplies to 72 and adds to 17. And people rack their brains and think the number that multiplies to 72 and adds to 17.
What's the 2 dots?
Go ahead.
7 and 9.
What are 2 dots?
I don't think so.
What are 2 dots?
I think it's 8 and 9.
What does 2 dots?
Oh, that just means that A is so that equals as well. Big deal like that. Okay? Sorry, 8 and 9 close, so 8 and 9. Okay? So if you take a look, the reason this one works, I will do lots of examples today, okay, right? It's just like before, 8 times 9 is 72, and 8 plus 9 is 17. And we'll go to the next word sometime today. Okay? Now this is the part you gotta wake up for, not wake up for, I didn't even say that. Okay? So you guys are an excellent class, okay? I put you down all the time, and I'm sorry about that, but overall you guys are a very, very good class, okay? And I don't say that enough, okay? Now it's the same way, so we're gonna do the same, what did we do with the 8 and the 9 before?
I don't know how you got m equals a times c.
So what it is, instead of just using c this time for the m, it's just going to be this times this always. Whatever's in front of the 6, or everything in front of the x squared, times everything, just the whole number. Okay? We'll do another one after. That's all you do, it's just like front and last, I suppose. Okay, go ahead. Yeah. I think for this, just for today, I think I'm going to go 6 with 9. It doesn't have to be, but like in this case, 6 and 9 sort of go together a little bit. Okay, you don't have to, but yeah, go ahead.
I have no idea how you got here.
Okay, so if you're multiplying the 72 and adding the 17, right? 72 is 1 times 72, 2 times 36, 3 times 24 maybe, and you keep on going down and eventually there's an 8. Okay, and 8 plus 9 is 17, and 8 times 9 is 72. It's like everything where I say this is going to be scary the first time through. Everybody say this? It is scary the first time through. Okay? So we're going to do plus 9x. 8x will work fine as well. And then plus 12. Now, just like before, you decompose, that's called decomposition. The 17x changes to 9 times 8. Now, we're going to do the same thing as we did before. Okay? So, I'm going to take this first one. You sure you're right? Okay. What's common between 6 and 8, 6 and 9? What are they both divided by?
3x.
3, right? 3x, good. Okay? Because 6 divides by 3 and 9 divides by 3. Can someone else be brave and tell me what's left inside the brackets? 6 divided by 3 is?
2x plus 3.
2x plus 3, wonderful. Now, if you notice now, there's not just x plus something in the bracket, it's like different numbers inside the bracket, right? So you gotta pay attention when you're common factoring here. Okay, it's like the same thing we did, but just a little more heavy on the brain. You know what I mean? Not like severely heavy, but a little bit more. All right. Isla, what's that? What's common between 8 and 12? What can they both be divided by? 4, great. What's left inside the bracket?
2x.
Okay, why are we happy? Because we're always happy. It's math class. Jordan, why are we happy? Brackets are the same, which is excellent. Jordan, can you show off your giant brain, please? And show the class what the very last step is here. What is it, people?
In the first bracket, it will be 2x plus 3.
Right? Okay. So if you take a look, once you get like to here, it's all the same, right?
Wait, I don't know how you do the last step of these.
Okay, so all we're doing is here, and I tried to explain this before, I don't know if I'm going to do the y thing, okay? What you're thinking is you're factoring out a 2x plus 3. So that's, both these things are multiplied by 2x plus 3. So think of like foiling. So we have 3x is multiplied by 2x plus 3, and 4 is multiplied by 2x plus 3. So think of it sort of like a foil. That's, anyone else explain that better? Because that's all I think of it as, right?
Can you explain it to me?
You literally just take that from everything.
Alright. Can everyone close their eyes for a quick sec? Put your heads on their desks.
Put it in the
Okay, here we go. Who sort of understood mostly this question that we just did? Okay, who feels sort of okay? We could use a lot of practice today. Perfect, that's what we're doing today. Who feels awful? Who needs a hug? You're not getting a hug from me. You're not getting a hug from me. You're not getting a hug from me. Okay, who can I help? Nothing to go with the last one. You know, I got something weird though. Hopefully the internet's not hearing this. My twin brother doesn't know like anymore, right? So he's at my house,
Okay, and then you
and I hug him all the time. You know, and I kiss him on the top of the head, and he's like, he just says this to me all day long. He doesn't
But
like
you
it.
take it back.
All right, here we go. Example 2. Do you guys want to try this one, or do you want me to do one more? One more? I'll do one more. Okay.
How do you get from
Letter B.
2x?
Wait, it was a 3x? Oh, then I have no idea. No idea, I have no idea.
Okay. So what happened?
How did you get 3x instead of 2x?
You're taking both these out, and then 3x here.
Oh.
So like this 3x, 2x plus 3.
So you bring this bracket down and then kind of get rid of that and use those two?
All right, here we go. Let's.
If that was a -4, would it be -4?
All right, here we go. So this is where the first step. I'll let you guys do the rest after doing the first step. Let's see M and the A because this is the hardest. Excuse me, please. Excuse me. Thank you. What's the M and the A? Go ahead.
2 and 6.
Sort of. Yeah, it is 2 and 6, sort of. But it's supposed to be, I say -12. How did I get -12, please? Go ahead. Yeah, I just did this and this. Right? That's your M now. And this is your A. Okay? So my adding is going to be -1. All right, so the m is always just gonna be the first number, like the a is called the a, the x squared coefficient, and times the last number there. Yeah, fine.
Is it already the same thing you just did on the last question?
What's that?
Already the same thing you just did?
Yeah, yeah.
How can you do that?
I did 6 times 12. That's what I was trying to show here. That's what I was trying. Again, I don't know if it was clear, but that's what I was trying to show on that one, right? So again, it was 6 times 12. That's what I was trying to show. 72. Okay,
I
so
get that confused everyone, or at least it confused me a lot.
okay,
Like
it's
the-
first times last. It's multiply. Okay.
All right.
It's
And
just
then the middle ones you're what
adding,
you're adding to?
always, yeah.
Okay.
Okay, here we go. Do you want me to take it through?
Yeah.
Yeah, but how is it, how's the m negative?
Because 2 times negative 6.
Okay, I
Right?
understand.
First time last, right?
Yeah, put that M.
No. You do not need to do this. You probably don't need to, yeah, I'd recommend doing this. Just to show you guys where the m and the a are coming from top and bottom there. Okay? All right, here we go. Multiplies to negative 12, adds to negative 1. 12 would be,
Is it negative 4 and 3?
very good. Okay. Okay, now, this is what I tell my classes every year. There are always numbers that go better together. What goes better with 2? 4 or 3? Yeah?
4.
I would say it does too. You can still do 3 and get a correct answer. Like you can do both ways and it still works. But for me, I look at 4. 2 and 4 work together nicely. Okay? So I'm going to do this again. 2x squared. And minus 6. Okay, so in the middle then turns into minus 4x. Plus 3x. So again, you could have done it the other way and still get the right answer, but this one seems easier to me because 2 and 4 go together perfectly. Good, thank you. All right, here we go. Can I get another brave soul that wants to factor? Go ahead.
2x.
Yeah,
And
great.
then in brackets, x minus 2. And then 3 in the brackets, x minus 2. And then the
Okay, hold on. You can give me the answer in a sec. That was a lot of math you just did there. It's great math. Okay, for the rest of the class.
Wait, let me get the answer. I got this.
Okay, hold on. Just hold on.
Is
So-
this
This is a great common factoring that Ms. Zacharias did with you. Remember that a long time ago? So what she did is, right, hopefully, we showed you this. We can divide both by 2x, right? And that comes down 2x times x is x squared, 2x squared. 2x times negative 2 is negative 4x. Okay, and then 3x and negative 6. All right, Lauren, I'd like to be brave and give me the final answer, please.
in brackets x minus 2, and
Yeah.
then more brackets 2x plus 3.
Lovely. And tomorrow we're going to talk about graphing. We did this already. Remember axis symmetry and all that stuff? So we factor to get x-intercepts. Okay. Any major questions before I let you try one by your own self right now? Any major questions? If you have a major question, raise your hand, and I will try and help. Okay? But as you can see, it's a lot like what we did before. The only difference is that first step, right? Okay? I have that. This is C, or 3, or whatever it's called. Let's do a hard one this time.
And those weren't hard.
There you go. That's my hard one for right now. Okay. So I'm going to hit pause in the video. You guys going to try this one, hopefully? I said, well, I mean, you're actually going to try this one, but I'm going to. For